Hey guys, this is just a fairly brief video, hopefully helping you understand how linear equations, which we've solved in term one, how these linear equations can be represented graphically. Because this term we're going to be doing a fair bit of work with linear equations and the Cartesian plane. And it's important to understand the general form of a linear equation and how that can be applied to any linear equation to represent it graphically. Okay, so on my screen here, I've got just the learning intention up, and that first dot point in the learning intention, understand how a linear equation can be represented graphically, is the topic of this lesson. So I just want to scroll down past the Cartesian plane stuff and look at this linear equations. I've got here a few dot points which I'm just going to read out. A linear equation is an equation which represents a straight line. So perfectly flat, no curving, just a straight line. And the general form of a linear equation that we're going to go through today is y equals mx plus c. Now y and x are just your coordinates on your Cartesian plane. So you've got your x coordinate, your x-axis rather, and your y-axis. That's what those y's and x's represent. And the m and the c are two variables which change. So just a quick sidebar, in the orange you'll see there that I've discussed that in senior mathematics, so in year 11 and 12, especially general mathematics, we use the equation y equals a plus bx. A is just your c and b is just your m. So it's the same formula, it's just rearranged a little bit differently. So just keep that in mind. So if you see them, they're interchangeable, they're kind of the same thing. So for our equation y equals mx plus c, m in green is our gradient. So that tells me how steep my line is basically. If it's a number bigger than 1 and much bigger than 1 even, it's going to be really, really steep. So for example, I've got there y equals 10x is a very steep line indeed. Whereas if that number is smaller than 1 and actually getting closer and closer to 0 for m, your equation is going to be, instead of being really steep, it's going to start getting flatter and flatter and flatter. And c is the y-intercept, and that number just tells you where on your y-axis, so your vertical axis, where up and down here does the line pass through. So if the bottom of this sticky here is y equals 0, y equals mx plus 1 for c would be passing through here. Y equals mx minus 1 would be down here at minus 1. And I'll show you that on Desmos rather than just using my Apple Pencil here. So I'm going to switch over to this app called Desmos, which I've just clicked and dragged here. If you don't have Desmos, I highly recommend you getting it. It's a really powerful app, and I'm going to show you how you can use it here. So you'll notice on the left-hand side, I already have a bunch of linear equations written in, but they're not on my Cartesian plane because I've currently got them hidden, and I'll show you why in a second. But up the top here, I've got a little plus, so I'm going to click that, and I want the top one, an expression. So here, I'm going to write the general form of my equation, and this is where Desmos can be really powerful. I'm going to write y equals mx plus c. Now I've got a keypad. I'm going to take the keypad off because it's probably going to mimic your iPads a little bit better, and I'll show you that again. I'm going to write y, and if you're on this screen and you want to get to all those letters, in the bottom left you've got an ABC, just click that. So I'm going to go create another expression. I just got to get rid of that y there. This expression here, I'm going to go y equals m, so I've got to switch to the ABC, click my m, and then x straight after it, and go back to the numbers. I'm going to go plus, back to the letters, c. So I just want to write y equals mx plus c, and I might even click and drag that one to the top. And you'll notice underneath that equation there, it says add slider, and then it says m, c, and all. That means that Desmos has recognized that m and c are variables. Variable meaning the value can vary, it's going to change. And so it adds a slider so we can actually see what happens to that line as we move it. So I'm going to say, yes, I would like to add a slider for m, and I would also like to add a slider for c. And now the slider is something I can click and drag. So if you followed these steps on your iPad, you should be able to click and drag these sliders around and see how that's going to change your linear equation. This red one here is our linear equation. So if we change c to 0 for now, like that, you'll notice that my linear equation, or my line, goes through where y equals 0. So my y-axis is my up and down axis here, and it goes straight through y equals 0. If I change that, that value of c to 1, it should move my line straight up until the line, from your perspective, I think it's this, is passing not through 0, but rather through 1. So if we change that to there, c equals 1, now my line passes y equals 1. If I change it to c equals negative 2, it'll drop my line all the way down to where it's passing through c equals, y equals negative 2, right? Nope, it's really hard to do on my iPad, and I'm sure you'll understand. Oh, I can actually tap it and change the value to what I specifically want. That's cool. I'm still learning. Enter. Cool. C equals negative 2. Great. Now if I change my M slider, rather than clicking in, I'm going to click and drag the slider. You'll notice as this number gets bigger, my line is going to get much steeper. And as I make it much smaller, maybe less than 1, it's going to get flatter and flatter and flatter and get close to horizontal. So I'll make it bigger first. We start with the slider and we get bigger and bigger and bigger, and my line is getting steeper and steeper and steeper. And if I start going down now, it's getting flatter and flatter and flatter. We get to 1, where it was before, and it's going to get flatter and flatter and flatter all the way down to 0.1. And if you want to take a second and think what's going to happen when I make it m equals 0, it's going to be perfectly, well, okay, I'm not very good at this, am I? I'm just going to write it in this time. M equals 1. M equals 0 is what I wanted, wasn't it? M equals 0, and it's a perfectly flat line. Now, follow-up question, if you're playing along, you can probably answer this already. When I go less than 0, or if I make this negative, what's going to happen to my line? Well, that's interesting. Let's find out. Let's go back to the slider and let's go more negative. It still stays a straight line, but this time you'll notice it's going downhill. If I'm reading from left to right, I'm going to be dropping a, if I dropped a ball on this line, for example, it's going to roll downhill because of gravity. If I make my gradient, or m, positive, if I dropped a ball now on that line, it's going to roll down to the left, and to get it further to the right, we would have to actually push that ball up that hill. And again, if it's negative and we dropped it, to get the ball further to the right, we would just let go and the ball would just roll down the hill. So when m is positive, we have a positive gradient, which means my line from left to right goes up. If we have a negative gradient, or m is negative, from left to right, my line goes down. Okay, that's really important to understand that. So with these sliders in mind, have a play with them as well. And I'm just going to turn this one off now because I want to start turning on these other ones so you can have a look. I want you to think about what is y equals 4x plus 3 going to look like. Okay, pause the video if you want to just think about it before going ahead and doing it, which I heavily encourage. If you've paused, cool. If you've come back, I hope you've realized at the very least that it's 4x plus 3, meaning my line should go through where y equals 3, okay? And that's the first thing I look at when I look at a linear equation. I look at where is it going to go through the through the y-axis. It's much easier. It's just that number at the end. So this line should go through y equals 3, which is at the top of my screen now. And it has got a gradient of 4. So it's not going to be flat because that's x equals, that's m equals 0. M equals 1 is 45-degree angle to the x-axis, and as we get bigger, it's 4 times steeper than that, so it's going to be pretty steep, this line, and it's going to go through 3. So if I turn that on now, yep, it's pretty steep, and it goes through where y equals 3. And I can zoom out, and these lines are never ending. So even when my axis gets to the tens of thousands, it's still a perfectly straight line, and that's really important to understand as well. But if I zoom right in, you'll notice my red line here cuts the y-axis at y equals 3. Y equals 2x plus 0 is the next one. 2x plus 0, well, plus 0, that means that y is going to be 0 where the line goes through it. So it's going to go through the origin. And 2x is not going to quite be 45 degrees, going to be a bit steeper than that, but not as steep as 4x was before. And that's right, that's where that one goes through. The next one, y equals 0.1x plus 1. So again, I'd start with the y-axis. It goes through where y equals 1. So it's just going to be above 0 at y equals 1. And 0.1x, now this is below 1. Remember, this is y equals 1. And we're not quite at 0. That's a flat line. We're just slightly above flat. So it's going to be quite a flat line, but not quite horizontal. Notice that? It's not quite flat. It's up a little bit because of 0.1, and it goes through where y equals 1. Y equals x minus 1. Now in this one, we look at the last number, but it's important to note that my last number is not just 1, my last number is minus 1. That means that this line is going to go through when y equals minus 1, not 1, but minus 1. And x doesn't look like it's got an m in front of it, but this is just because m is 1. And when we times anything by 1, it just stays itself. So instead of saying 1x, we just say x, okay? But technically the coefficient of x here is 1. So it should be just that standard 45-degree angle line here. And it's going to go through y equals negative 1. See that? Down here at y equals negative 1, and it's a pretty standard 45-degree line. The next one is negative 2x plus 1. So I'm pretty sure, by the way, this whole time I've been doing the correct orientation with my hand. I think I have to actually do it in reverse, but hopefully it's working. If not, that's a bit of a bummer, but you can still see on the screen. So for negative 2x, it's not only going to be negative, so it's going to flip all the way around like this, but it's also going to be quite steep because it's twice as steep as this one. So it's going to be more up like this, but in the negative direction. And it goes through when x equals 1. Okay, so it's going to go through where y equals 1, sorry. So if we turn that one on, there we go. It's a negative gradient, quite steep, and it goes through y equals 1. And the last one, before I let you go, is y equals negative 3x minus 3. So again, this one's a negative gradient, so not positive, but negative. It's negative 3, so it's quite steep indeed, and it goes through when y equals negative 3, so that's going to be further down my screen here. I'll put negative 3 in the center of my screen, and that's where my line's going to go through in a negative, pretty steep direction. There we go. So this video was hopefully, if I go back to my learning intention, hopefully to help you understand how linear equations can be represented graphically, because we've graphed a bunch of them. We talked about what m equals, the gradient, the steepness of my line, and also the c, the y-intercept, where it goes through the y-axis. As long as you understand that your Cartesian plane has an x-axis and a y-axis, and a line is going to go somewhere on that axis, and you understand that m represents the gradient, the steepness, and c represents the y-intercept, or where the line goes through that center y-axis. I think you're well on your way to understanding linear equations, and you're going to be really good at solving them.